Okay, so we got this situation. How many triangles can be formed by joining the vertices of an n-sided polygon? Okay, how many of these triangles have exactly one side common with that of polygon, exactly two side common with that of polygon, no side common with that of polygon? Okay, so we will handle this situation one by one. First, try to handle the first case in which we have to count the number of triangles which will have exactly one side in common. So suppose that if I'll ask you to find out the number of triangles, you know that if we will deal with uh, the number of triangles directly, you can answer, sir, it is NC3, है ना? But look at this situation. Suppose that this is the case, okay, and this will keep on going, this will keep on going. So we guys are interested in finding the number of triangles corresponding to this side when it is common with the triangle as well as polygon. Okay, you know that to find out the number of triangles we need to have 3 points, out of which we have already collected 2 points. We need one more point. Okay, now look at this. You know that all together there are n points. So just tell me, will you allow me to take this point? You will say no, because I have already taken those 2 points. So if I'll take that point again, it won't make a triangle, correct na? So it is not allowed. Will you allow me to take this point? Neither, because you know that again it will be in the same case. Do you think you will allow me to take this point? No. Why? If I will select this point, no, you will have a triangle which will have two sides in common, correct? But we are interested in what? We are interested in finding one side in common. So this is not the case. Okay. Now, will you allow me to take this point? Again not. Because if I will take that point, again we will have two sides in common, which is not required case, correct? So now look at this. I want to select this point. Okay. I want to select this point. Will you allow me to do so? Yes, you will. Because look at that. We will have a triangle, है ना? And we will have only one side in common. So it is okay. This means that corresponding to this side, you have restricted me to take this point, this point, this point, and this point. So out of n points, you are restricting me to take 4 points. And now I am free to take any one of the point in that zone. Means, can I say that corresponding to the side 1, we will have n minus 4 C1 number of triangles. Okay, required number. Is that okay? And you know that if it is like corresponding to this side, we will have this many triangles which will share one side in common with the polygon. We have so many sides, no? So if there are n vertices, we will have n sides. So can I multiply this with n to get the required number? So the total number of triangles that will be sharing one side common with the polygon is n times n minus 4 C1. I hope first part is clear. Okay, now let's move on to second part. Exactly two sides common with that of polygon. So suppose that we are dealing with this. Okay, okay, so it is 1, 2, 3, 4, 5, 6, 7, 8. Now be super slow and try to observe what I am taking. A, B, C, D, E, F, G, H. So we are dealing with octagon. Right now I am dealing with octagon. Later I will generalize it with n-sided polygon. Okay. So look at this. I will go anti-clockwise direction. Okay. And we are interested in finding the number of triangles which will share two sides common with the polygon. So can I go with AB, BC, AC? Okay, so what I did, I have connected A, B, C. Correct? Now look at this. Now I am taking next. I will go with B, C, D. Okay, so it is BCD. Triangle BCD. Now I will give preference to C. So C, D, E. Okay, triangle C, D, E. Now I have to give, we have to start from D, D, E, F. Okay, so triangle D, E, F. If you will observe, every triangle is sharing exactly two side common. Correct now? Now I have to give priority to E. So E, F, G. Triangle E, F, G. Now F. So F, G, H. Triangle F, G, H. Now I will talk to G, G, H, A. Okay, triangle G, H, A. Now let's talk to H. Okay, H, A, B. So it is triangle H, A, B. Now if you will take A, you will have ABC, which we have already connected. Correct now? So this many triangles are possible if it will share two side common. So the for octagon we got 4, 4, 8. We got 8. So if it is octagon, we will have 8 triangles. Nonagon, 9 triangles that will share two side common. Now, if it is n-sided polygon, can we say that required number of triangle would be n? Because for octagon we got 8. Nonagon we will get 9. Decagon we will get 10. So similarly, polygon with vertex n, we will have n triangles that will share exactly two side common with the polygon. Correct, wrong? Correct na? Now let's move on to the third part. Look at this. So in third part we have no sides common with the polygon. So can I say that from required number, can I go with all triangle minus one side common minus two side common? Just tell me. So from all triangle, either we will have one side common, two side common, we cannot have three side common, na? So we are subtracting the number of triangles that will share one side common and two side common. So you know that if it is n sided polygon, we will have n vertex. So we will have n c 3 number of triangles. Now exactly one side common, so it is n times n minus 4 c1 triangles minus two sides common. So for two sides common, right now we have calculated n. Okay, so this is the number of triangles that will share no side common with the polygon. I hope the idea is clear.